Hi, ladies and gentlemen. So we're going to go through this formative real quick. So it says that in the formative that little Susie and the purple rhinoceros just received a new air track for their toys. They're on the air tracks. They're setting out the air track with a photo gate near the end to measure the car's velocities. The red toy car has 154 grams, was recorded, and has an initial velocity of 4.25 meters per second as it passes through the first photo gate and collides into the blue car, which has 77.0 grams and is initially at rest between the two photo gates. The blue car then moved through the second photo gate and recorded the blue car's velocity to be 5.45 meters per second, and the red cars then went through the second photo gate with a final velocity of 1.32 meters per second. So the first thing I did want to let you guys know is just like in case you didn't know what a photo gate was, this is kind of what it looks like, at least when we set it up in our class, where we have two of them. We're going to put them over that air track that it's kind of like any other track for a car, like a Hot Wheel track, except for it blows air through so that the cars don't hit the surface. So you're going to put them in two different spots. So our cars are going to go through them, and as they go through, there's a sensor right around here, and that sensor is going to identify the velocity going through that sensor. So that's how our cars are being measured with their velocities to be pretty precise. So if I'm drawing my cars, I'm going to draw them with my different colors and I'm going to label them. So we have our red car first. So I have my red car. It's not going to be very good, but we have my red car, my lovely red car moving with its initial velocity of 4.25 meters per second. And it's got a mass of 154 grams, which is equal to 0.154 kilograms. Remember, when we do momentum and impulse, we are always using kilograms, which is why we need to convert at some point. I'm just going to do it right here. Then we have our wonderful photo gate, which I'm just going to put as a dotted line because I'm not going to be able to draw my photo gate well. So I'm going to have two of them for the one on either side of our blue car. And our blue car is sitting in the middle. And it's not moving, so its velocity equals 0. And its mass is 77.0 grams, or 0.0770 kilograms. Our red car is going to collide into the blue car, and then they're both going to be moving together after this second, or they're both moving in the same direction after this second photo gate. So that's the before. After, we have our red car and we have our blue car. They're both going in the same direction. They're both moving in that same direction. So we're going to draw them both moving in the same direction, and we can include those velocities of 1.32 meters per second. And this is still the mass of 0.154 kilograms. And then our blue car is moving with 5 meters per second. And its mass is still 0.0770 kilograms. So we have our before and our after. The next question says, what is the momentum of each car before and after the collision? So what we're going to do is we're going to start with our red car. So before and after. Before, we have our mass times our velocity, so 0.154 kilograms times the velocity, which was 4.25 meters per second, gives us our initial momentum, our starting momentum here of 0.655 kilogram meters per second. This is going to be the red car before and the red car after. We have our mass, which is still the 1.54 kilograms, times our new velocity of 1.32 meters per second, gives us our final velocity of 0.2, or final momentum of 0.203 kilogram meters per second. Then we have our blue car, which has an initial mass of 0.0770 kilograms and initial velocity of 0 meters per second, giving us a total initial momentum for that one of 0 kilogram meters per second. And our final velocity, the velocity or the momentum after the crash, we have our mass is still 0.0770 kilograms times our velocity, which is 5.45 meters per second, to give us our final momentum of 0.420 kilogram meters per second. Remember that we're going to say that all of these are going in the same direction, or the positive direction. You could say they're all going in the negative direction if you wanted to. That's just up to you. It really does not affect your information. If we're finding the change in momentum of each of our cars, we're finding the change from our final momentum minus our initial momentum. So if I'm going to do the blue car first, change momentum equals the momentum after minus the momentum before. And so that's going to equal the 0.420 kilogram meters per second minus 0 kilogram meters per second. And that gives us the same change momentum of 0.420 kilogram meters per second. Now we're finding the momentum of the red car, that change in momentum. We have the same equation, so our momentum after minus the momentum before. And so we're going to have the 0.203 kilogram meters per second minus the 0.655 kilogram meters per second. And we're going to get a change in momentum of negative 0.451 kilogram meters per second. And so as we can see that our momentum, our change in momentum got larger as our impulse is larger in the blue car because we started from 0 and then we sped up, versus our red car, our car slowed down. So our change momentum became negative. All right, so it says, what is the percent difference of the two total momentas? So before the collision and after the collision. So this is where things got a little bit tricky for a lot of people, was this question, because we need to remember two things. The first thing is that it's saying before and after, which means that we want the total before the collision and the total after the collision, and that's what we're comparing. The other thing is we're looking for that percent difference. So we got to remember that percent difference equation. So I'm going to write right here. So a percent difference is going to be, I'm just going to use x1 and x2. So it's going to be the difference between x1 and x2 divided by the average, or x1 plus x2 divided by 2. And then we multiply the whole thing by 100. So it's x1 and x2 are just random variables, just to give us an idea of what's going on. So if we do this for real, the first thing we need to do is know the total before and the total after. which means we need to find the total momentum before the collision and find the total momentum after the collision. So if we're doing that, we are going to take our values from up here. So we have 6.555 plus our 0, and that is just going to give us our 6.555 for our total momentum before, because only the red car had momentum before. All right. Now for the second one, we're going to take our 0.203 and we're going to add to it, we're going to add that 4.20. And we're going to have 0.623 kilogram meters per second. Now we can take our percent difference. So technically there's absolute values here because we want to make it positive. It doesn't matter which one goes first in this case. So I'm just going to put the larger one first to make sure it's positive either way. So I'm going to do my 0.655 minus the 0.623. And then we're going to divide it by the average, or 0.655 plus 0.623 divided by 2. And then we need to multiply this whole thing by 100. So when we do this, when we do the top, we are going to have absolute value bars can go away since we don't have anything negative. We have the 0.0. Add it and then minus 0.623 gives us a 0.032 divided by the 0.655 plus the 0.623 gives us 1.278 divided by 2 times 100. And then we can go one more time and we can divide that by 2. And now we have 0.032 divided by the 0.639 times 100. All right, and if we do our 0.032 divided by 6.639 and multiply by 100, we are going to get 5.01%. So a very small percent difference here, not too bad. When we do this now, so now we have to explain. So this is our percent difference between the two. So before and after our collision, that is our percent difference between those two. And question 5 says, little Susie noticed that that when the cars crashed, the red car's side mirror broke off and went flying. Which direction did it go? The same direction or as the red car, or the opposite direction? Defend your answer with evidence from the above calculations. So that's the big thing I did see a lot of people missing, if they did it correctly, was lacking evidence to support it. So don't forget to explain why with the evidence. Don't just tell me it's going in some direction because that's what you think. We want to make sure we're including data to help support that claim. So when we're looking at this, the big thing to notice is from up here, the biggest part that I would have noticed is this section right here. The fact that because we have this percent difference, it's not 0. That means there's a change in our momentum. And if we look, our momentums aren't the exact same in this problem. But we need to remember that the law of conservation of momentum says momentum can't be created or destroyed. That is something we should have gotten from the overall pogo, is that momentum is going to remain constant. It's not going to go anywhere. If it changes, it has to go somewhere else. So it can only be transferred. It can't be created or destroyed. So that means that the total momentum before and after the collision should be the same. And as we can see, when we took the difference up at the top, there was a difference of 0.032 kilogram meters per second. This difference means that the momentum of that side mirror wasn't included in our total calculation. So now we have to figure out which way our side mirror was going so that our momentums would be the same. So if we look, our momentum after the collision is smaller than our momentum before. And before the collision, we had that side mirror, which means there has to be more positive momentum to add up to that negative to add up to the missing momentum. So the side mirror has to go in the same direction because our momentum after is less than the momentum before, showing there was some momentum missing from the side mirror. As always, if you guys have questions about this, please let me know. The one thing for a 4, it does say to support the mirror's velocity. So if you wanted to go for that 4, you need to explain about the velocity and especially about the fact that that side mirror probably doesn't have a lot of mass, which means it has more velocity. So that one is based on Newton's first law, where an object in motion is going to stay in motion with the same velocity unless acted on by an outside force. Because that side mirror flew off, it's going to continue going with closer to its same velocity that it had at the start, which means its velocity is going to be larger than that 1.32 or 1.32 meters per second that the initial that the red car had at the end of the experiment, the activity.